Now, the other thing that's interesting to note is that, this standard is significant in the sense that we're really asking them not to just find these random angle measures and not just to measure a bunch of B's, a bunch of rays with common endpoints, but we've got to be able to put them into shape. And so we probably need to have had that shape instruction prior to looking at the standard. Okay. So then let's look at 5th grade, and then we're going to look at a couple other pieces here. 5th grade, we then take, it's interesting because 3rd grade is all about the area, and it connects horizontally to the vertical, to the number sense standards that they're doing. 4th grade, we kind of take this time out and we add the angle measure, but we might still, we still use the same properties as far as additive nature of angles and whatnot. So then in 5th grade, we move on to volume. And so again, what we have to be careful of, and I will say this so many times you'll probably get tired of me saying it, but we have to be careful that we don't forget about paying attention to the attributes. And I say this because many, many times when I work with children in these grade levels, they don't stop and think about that. And so they just start jumping in and they just start working problems and they don't think about what attribute is being measured. And so you see here with these standards 3 and 4 are very much parallel to what they had in 3rd grade. Now, next year's 5th graders probably will not have had the Common Core in 3rd grade. So you will probably have to go back and revisit what an attribute is, revisit, and really clearly define what these unit cubes are and what they can measure. And again, you'll see the parallelism here with 4th grade, that we have to have this filling, this measurement of volume with no gaps and no overlaps in order to completely measure. And you see you start with the counting there with standard 4, measure volumes by counting unit cubes using cubic centimeters, cubic inches, cubic feet, and improvised units. So we're, again, to be in concert with the way 3rd grade is laid out, we start by the understanding of the attribute. The attribute we're dealing with is volume. We're going to measure it, which means we're going to put a number to that. That's the concept of measurement. And then we're going to physically fill things and count unit cubes to kind of, reinforce what this concept means. So this is still the concept of measurement. Then we get into more of the process of measurement, where we're relating volume to multiplication and addition, and then solving real-world problems. Now, a lot of people say, okay, so what are the volumes we have to find? And so you hear we have right rectangular prisms, which are our old good old friend, the box. Letter A here is very specific and very clear what we're doing here. So we're going to have them measuring the volume of boxes and with whole number side lengths, and we're going to pack it with unit cubes, and we're going to show then that they are two things, and this is very important. Not only that volume is length times width times height, but volume is the area of the base times the height, because that more generic definition of the stacking of the base is going to help them with other shapes than in future grade levels. And so then we're going to apply the formulas, but that's after we've done all this other work. So the formulas come after. Remember those 5 shifts? We're not just giving them the formula to drill, drill, drill. We're developing the concept first. And then we get back to our, vertical coherence piece that we've done in 3rd grade and in 4th grade, that not only is area additive, not only are angle measures additive, but then volume is also additive. And this becomes especially important especially if we have big numbers to work with or a very unusual figure to find the shape of. So let's look at a task that might be a little boring to look at first, but has a little bit of a twist to it. So we have our old friend the box, and it's so many centimeters high, wide, and long, and it can hold 40 grams of clay. So it's relating that idea of volume to mass. And now we're taking a second box and changing those dimensions and asking how much clay it can hold. And so the child has to understand that when we actually multiply the height by 2 and 3 times the width and the same length, what happens to the dimensions, and then they have to relate that to the idea of how many times bigger is the box, so how many times more grams of clay can it hold. And so this is kind of a problem that has a two-step approach where they've got to move in and out of the attributes and not just find the volume of the new box, but then relate it to how many grams of clay it can hold. So this task, again, can be very rich if you help students see that they can move in and out of those units. Okay, so I wanted to take a minute then to talk about these standards for mathematical practice before I show you a couple of websites to finish up for today. And the first one is this idea of which of these standards for mathematical practice, first of all, fits best for today. And so I would say, especially with, you know, this last piece was volume and changing dimensions, we're going to be looking for patterns, which is number 8. We definitely have an opportunity to critique the reasoning of others when we have more than one kind of, you know, argument going on, as well as then, you know, of course, modeling with mathematics, but using those appropriate tools. And again, you want to be careful when you're doing this that you always refer to the attribute being measured, because and the volume is even more problematic, because here we go. I'm going to take all these linear measurements and I'm going to do this math magic to it, and then I'm going to pop out this volume. And that's what gets very confusing to students. And so I'm hopeful that if we can focus on, you know, the different dimensions, the area measurement in 3rd grade, the angle measurement in 4th grade, and the volume measurement in 5th grade, that focus will help us spend more time with each of those attributes rather than taking the old approach, which is typically, you know, working with 3-dimensional shapes and trying to find all these different attributes of them. And the fact that we are sticking with the volume of, you know, our old friend the box. So that could definitely help. I would not be able to talk about this without also mentioning that we need to be also sure that we're having kids estimate. And so we want to think about this idea, this cycle, and I'll go back one slide because this would be a great slide. This would be a great task for us to, use this process on, where we estimate what the volume would be or draw this to see what it would look like. And then we measure the actual box and we see the actual volume. And then we estimate a new situation based on the first experience. And so how would that hold here? Well, we would want to take this box and probably build it. And, you know, you wouldn't have to necessarily even worry about the clay, but then talk about, okay, well, if it has twice the height, 3 times the width, and the same length, what would we, once we find the exact volume here, what would we estimate that new volume would be? And so that we're basing our estimate on an actual situation. And how close were we the first time we made an estimate? How then can we use that experience to measure, to estimate in this case? So then we have a sense about whether or not we're correct. And so please don't don't underestimate the power of estimation with these tasks. And so it's important to keep those in mind as you look at these standards. So let me get out of the PowerPoint here for a moment